Okay, so good morning everyone. Welcome to lecture 13 of Introduction to Programming. And as promised, so from today onwards, we'll start talking about pointers. Now, many people are sort of quite afraid with pointers, but one shouldn't be. I mean, it's a very simple concept. So we'll take a look at it today, and obviously we'll see some examples of that. So let's start with that. So let me just go to the terminal, but before that let's try to understand what pointer is, right? So over and over multiple times we have looked at that variables. So where are all these variables are sort of stored, right? You require some space to store a value that you write to variable, and then you read from those things. So that are basically, there are these memory locations. Your computer have, let's say that some computers have 2 GB RAM, 3 GB RAM, 4 GB RAM, something like that. So there is concept of memory, and every memory location have with it, which is the address, that what is the location of this particular cell of the memory. So let's say that, without loss of generality, let's say that this is 100, this is 101, 102, and so on and so forth. So these pointers are nothing but, you remember in the earlier lecture we have said that for any type, usually we can say that type is set of values and set of operations. So types are defined by these two things, that what are the set of values that it can take and what are the set of valid operations on the object or variable of a given type. So for pointers, these set of values are nothing but set of addresses. So that means that in your memory, whatever are the set of addresses, so that form the set of values. And regarding the set of operations, we will see that what set of operations you can do. So typically for pointer, the only thing is that what are the things that you can do, let's say. So pointer is something essentially. So now imagine that there is another variable. So let's say that this is 100, 101. Now imagine that this at location 100, you have a variable for which the variable name is let's say v. Okay, so the name is v, and let's say the content of this is 5, right? So you have, let's say, int v is equal to 5, but the address of v is 100. Now what you can do is that you can say that I want an integer pointer. So it is a pointer that is going to point to an integer variable. So two things that are there. So let's say that I say that p is equal to, and then this is the address of operator, this is a single ampersand. So you want address of v. Does it mean, so ampersand v is going to give 100, but it is not only the value of 100, it is what is also embedded in this declaration is that not only that the value of it is 100, but this particular cell, the thing that you are pointing to, it has the content of type int. So it is pointing to an int variable. Now the thing is that the p itself is a variable, right? So p itself is a variable. That means that also must be having some memory location. So let's say that p is here. So this is p. This is, let's say, 103, 4, 5, 6, 7, 8, 9, right? So address of this is 109. What is the content of p? Content of p is 100. So it is just a variable, but the value stored inside it is some address. So it is pointing to, p is pointing to v. So that is what you call it. And not only that, you have this extra additional information that not only it is pointing to the variable v, but you also know that it is pointing to a variable of type int. Now one can think that okay, because P also is a variable and it has an address, what you can do is that you can say that I can take its address as well. So I can do something like int pointer P1 and take address of P. So let's say that P1 is here, this is P1, this is 10345, this is 105. What are going to be its content? Its content is going to be 109 because it is pointing to P. So P1 is pointing to P, but what is the type of it? It is a pointer to a variable of type int pointer. Right, because P is an int pointer, so P1 is pointing to a variable of type int pointer, so that's why it is pointer P. And now I can keep on going, I mean, but it's all the same thing, right? I mean, if you understand, this is all, it means that you are pointing to some variable of some type, and that's what you are storing. So now I can have star P2 is equal to, you can, because this also has an address, so I can do something like this. What does it mean? It means that P2 is pointing to P1 and the type of P1 is, it is a pointer to an integer. Right, so let's say that P2 is here, let's say this is P2, let's say, without loss of generality, the address is 205 of this location, and P2 wallet, what will be the content of P2? P2's content will be 105, and you can keep on going. Right, so that is what it is. In a very short thing, pointer is nothing but the set of values that you are storing is an address of some another variable, and also in the declaration you specify that what is the type of that variable. Okay, so the operations on this thing is that basically you take an address and then what you can do is that you can dereference, and that we will see its usage now on the, let's write some program and let's see its usage, right? So let me start with this. So let's say that int a is equal to 5, and I will say that it is a pointer to an integer and you want to take its address, and I want to take address of this. And now I'll show you that this entire chain that we have made, that chain is indeed there in the program, right? So let's print. Okay, so I'll say that okay, value of a is %d and address of a is, so if you want to print a pointer, the specifier, the format specifier is %p. Okay, so value of a we want to print, which is just this, and I want to print the address of a. So so star p and ampersand a is going to be the same thing, but let me just follow this format. So it is this, and now let me just copy this thing, and I'll say that okay, so value of p is what? So now, but p is a pointer, so now I have to change this. Now onwards everything is a pointer. So value of p and address of p. So I'll say value of p and address of p. Similarly, now I want to do it for p1. Okay, so let's try to compile and run this program. So as you can see, it says that value of a is 5 and address is some hexadecimal number. So this is the is the address or the memory location, which is a sort of so A is for us, for humans, it is essentially at the end of the day this is the address where this value of 5 is stored. And now you will see that because we are saying that in P what are you storing the P, you are storing address of A. So these two things are going to match, that value of P and the address of A is the same. Similarly, value of P1 and address of P is the same, because that is what we are doing, and similarly value of P2 and address of P1 is going to be the same, right. So a pointer is nothing but it is a type where the set of values are nothing but addresses, and in this declaration you are saying that okay, P is pointing to a variable of type int. In P1 it is pointing to a variable of type pointer to an integer. P2 is a variable is pointing to a variable of type pointer to an integer. Okay. Now what I have done over here is the declaration is declaration and definition is in one line, but I can also, if I want to separate it out, just so that because there are different syntax. So if I want to make an assignment, then I can do it like this. So essentially P is, you are storing the address of A in P, right. Similarly, you are storing the address of P in P1, and you are storing the address of P1 in P2, and even this program and the previous program are exactly similar. Okay, so it's still the same, that these values will match, this and this will match, and similarly this and this will match, and similarly the value of P2 and the address of P1, they are all the same. Okay. Now that you have this address, so because you have the address, you can also access the content of the address, right. So what you can now do, so how do I access a content from a given address? So if I want to do that, what I can do is, so now what I am going to change is the following. So I am still printing the value of A and address of A, but since I know that P has the address of A, so I can also say that instead of address of A, I will just write P, because value of P is exactly the same as address of A. Now I can get the value of A by doing this. So I will say star P. So this star is a dereference operator. What does it mean? It means that look at the content of the address that is stored in P, right. So P is pointing to whatever this location, right. So this location is so P is pointing to, essentially this is the value. Star P means that you go to this address and look what is stored inside it. Okay, so then you will get value of A. Similarly, for P also you can do the same, that I can do star P1, yeah, and similarly I can do right. So now you see that I have introduced basically this one level of dereference I am doing. So star P is going to print the value of A, star P1 is going to print the value of P. So if had it been, so remember the syntax of printf, right? So if this is just, then it will just print whatever the value of p1 is. But if I do star p1, so then because p1 is a pointer, it will see that what does p1 points to. P1 points to p, so it is going to print the value of p. Okay, similarly this one is going to print the value of p1. Right, and since we don't have further redirection, I mean if we want we can do that. There is no harm in it. I can do p3. So star p3 is nothing but value of p2. And here I'll write p3. Okay, so let's see, let's run this program and see what happens. And you see that still the result is the same, that this address of A and value of P will match, this thing will match, similarly this will match, and similarly this will match. Now see, one thing to notice over here is that address of A over here, you look that address of A, let's say that last 4 hexadecimal digits is D86C, whereas this is 9224. So the takeaway from that is that every time you run the program, the address of all of its variable etc. may be different. Not only maybe, most of the time it will be different, right? So I mean that you can observe even from here, this run to this run. Because when your program is loaded, there is something called loader. So basically, when you try to run the program, the memory location at which all of these variables are allotted memory etc., these are all going to be different, right? So this part is, so essentially address of any particular variable is it's non-deterministic. So you should not write program which is dependent upon that at the time of execution this will be the address of something. No, you always have to take the address at runtime, because you will never know that where this will be loaded, right? So ampersand is the address of operator, and the star over here, when you use it like this, so it is a dereference operator, that you are dereferencing. That means the star p means that print the value of the variable pointed to by p, and p is pointing to a, so it is going to print the value of a. Now I can go even one further level of redirection, because you see that p1 is pointing to p. That means that I can do this. What does it mean? It means, so you can break it down into two layer. This one, so star p1, what will be the value of star p1? The value of star p1 is the value of p, and value of star p is what? Is the value of a. Okay, so that is how it is going to work. And similarly, now if I want, I can just do star p1 here. Okay, so and similarly I can change all of this here. And yeah, I don't have a p4 further, so we will not change anything, right? It is still the same thing, that basically this will match, and then this will match, and this will match. Right. So what does it mean? Since you know what I'm, so star P2 is exactly the same as star of P1, and similarly star P3 is same as star of P2. Now I can write everything as a function of P3, right? So if I want to write in terms of P3, what does it mean? So star will be the same as star P3, and this is going to be, right, because these two are same, right? So star P3, and similarly here I have to write two of these guys, and I will again have to add two of this. Now this is everything in the form of P3, and this entire chain you can follow, and please note that the fourth star is essentially going to is the same as this value of A, so because that is what the chain that we have made, right? So there are this 4 star which is the value of A, 3 star is the address of A or the value of P, right? 2 star is going to be what? So 2 star is going to be the address of P or the value of P1, and 1 star is the address of P1 or the value of P2, right? And let's see, does it work, right? So everything will match. So when you have a pointer and when you put a star along with this, that means that you are saying that I want to dereference. So this is one level of dereference. So this is what? This is printing the value of P3 over here. This is printing what? Printing the value of the variable being pointed to by P3. So P3 points to P2. So it is going to print the value of P2, which is the same as this thing. Star P3 means what? So you can think of it like, so this is how the parenthesis, this is how it is applied, right associative. So first you compute star of P3, which is what? Essentially it is value of P2, and then a further star on that. So P2 points to P1, so it is going to be what? Going to print the value of P1, which is what it is, right? So value of P1 is this. Okay, so I hope that this part is clear, and I can keep on going. I mean, one doesn't have to sort of that there is only 4 level of indirection. This is then, as much as I have memory, I can keep on doing that. I can take address of that, and then further I take address of that, etc., and then have this entire chain. Only useful value is over here is 5, and rest all of these 4 values are nothing but addresses. Okay. So now that you have address and you have already been using these addresses in your program. So let's see where have you used these address. So if you remember, right, what you do is scanf, you do %d, right. So you are asking a user that I want to I want one value of type integer, but the argument that you are providing is what? It is %a. So you are giving it the address of A, that whatever you read from here. So certainly, see, first of all, when you give input, everything is a string, and the scanf function, it takes that appropriate string, interprets it, converts it into int, and then stores at this location. That's why you are giving the address. Okay, so that is so let's run this program. This program you are familiar with already. Okay. and let's say value of 5, okay, no problem. But now what I can do is that, so remember that I have to give the address of A, so I can also do that. You declare a pointer and then say that P points to A. So you take address of A and put it in this pointer, and now instead of ampersand A you can just use P. And to prove the point that this indeed is of this thing, you see that you are scanning and you are providing P, but I am printing the value of A. So if P is indeed storing at the location pointed to by P is indeed A, then essentially these two values should match. L23, whatever I am going to print, because they are the exactly the same thing. This you have already been using it in your program. So in the scanf you are taking an address, but instead of taking an address you can also do it like this. Okay, now another thing that you have used these pointers without sort of explicitly studying pointers are strings. So we have discussed, right, that string is what? String is a character array. So let's say that this string is there, it is a string of you are just doing on that. And now when you do %s and then you give A, yeah, so this is going to conflict, right? So I am just going to delete this. So what you are giving here as an argument is this pointer, right? So what is a pointer? It is the location where H is stored, right? So that address is there inside A. So let me just compile this, right? And it is printing hello. So the type of A, so when you just write A without this index, the type of A is, it is an array, but when you write A is also, you can think of it as a character pointer, that it is a pointer pointing to a character. Which character? So right now A itself is pointing to H. Okay. Now what you can do, I can do something like this. So this is pointer, so if I do A plus, what does it mean by saying that I am adding 1 to a pointer? Okay, so let's again go back to the board. So we have these set of memory locations. Let's say that this is 100, this is 101, 102, and so on and so forth. Now when you say that, so when you say hello, right, I mean, so let's take that example that hello is HELLO, I don't know, maybe there was an exclamation mark, and you remember that there was a null character, because it's a string. We are not explicitly inputting, but because we have put it in quote, it is automatically going to insert the null character, right? So this is how it's going to look like: 103, 104, 105, some basically contiguous addresses. Okay, and now, so this A, so A is pointing to H. So what do I mean by pointing to H? That means that this variable A has the value what? 100. So whenever you say that A, it is going to point to this thing. So if I want to check this, let me just print a character, right? So I'll just print a character and I'll just say star A. See, I did not take an address, but internally this is how it works. So if I do star H, it is going to print star A, it is going to print H. It is pointing to a character. Which character it is pointing to? It is pointing to H. So by default, when you write A, it is essentially address of the first character of the array, and array means it's a contiguous memory location, right? So let's check this, right? So it just printed H. So that's what happened. And you will see that if whether I print so now let me just print two things, A plus 1. So let me just do this. So remember, so A plus 1, what is it? It's going to print. It is going to print. So A is pointing to over here, and plus 1 means that it's a pointer that is going to point to this location. And if I do a dereference on that, it's going to print small e. And let's check that whether that is indeed the case. Right, so it printed small e. Now what does it mean? It means that whether I do star A plus 1 or just do A1, both of that is going to mean the same thing, right? So coming back over here, so this A, when I say A has the value of 100 stored inside it, that essentially means that A is pointing to H. Now let's see. So what does for any pointer? So I am doing A plus 1, and this is where the type comes into picture. So when you do plus 1, you are saying that this is the offset, that wherever A is, this is the offset. So here it works out that because let's say character is 1 byte, so if you do A plus 1, it is going to be 101, and 101 happens to be this E. Plus 1 is pointing to E. So when you do any pointer and then plus some number, it means that you take this location and this is the offset. Offset means that you go add in that direction. And in fact, internally, when you do something like A5, etc., that's what happens. I mean, internally, that's what it does. It just does star A plus 5. This is there in the standard, and I think in one of the previous lecture, I showed you that that is how it does, that it does internally this thing, and that is why even this is valid, that you can do things like this, which is also still A plus 5. Okay, so that means that this is, when people say pointer arithmetic, what are they saying? That means that you can add a number to a pointer. So then it is going to point to the location that is sort of, one on the offset away from that location. So if I do A plus 5, this is going to be 1, 2, 3, 4, 5. So then A plus 5 is going to point to here. Okay. Now here this is a byte, but this plus operation it depends on what type of the pointer is. So if the type of the pointer is, let's say, int, right? So let's talk about int. So in int, what happens is that for an int requires 4 bytes altogether, right? So when you write 100 as an int, this is a 4 byte thing. So the address of this is let's say 1000. Then the next integer when will it come? It will come 4 byte away. So this can be 1004, let's say that this is 1008 and so on and so forth. So now let's say that you have a pointer that points over here, and then if you do a plus 2, then it is going to point to a memory location which is that much away, right? So it is a 2 integer location away. So since one int requires 4 bytes, 2 int is require 8 bytes. So this is same as saying that, you know, shift by 8 bytes. When I say shift, I don't mean value, but essentially the pointer is now pointing to 8 byte away from the memory location. And we can, so let's see that in action. And not only that, right? So if I do just a plus 1 without a star, what is going to happen? And I have to print %s, that it is going to print the string but which starts from a plus 1. So it's going to be LO instead of hello. Right? And you can just keep on doing like this. Let's say, you know, 3. So this is 0, 1, 2 and 3. So it is just going to be low, I believe. Right? And this also, I think that we have discussed once, that if you put a number and now the result is going to be undefined because you don't know, you are trying to access a memory location which you did not explicitly allow. So you don't know where this is pointing to. This may not be even belong to your program, and you are trying to access something. So your program could crash, there could be some, you know, another error, or it could print, yeah, something weird. So I don't know if you can see or not, it is some question mark inside a diamond, some such thing it printed, right? So you need to ensure that the memory location that you are accessing, you have allotted that memory somewhere, because otherwise the behavior is undefined. Now I talk to you about integers, right? So let's talk about, right? So let's say that I have int and okay, so these are 10 integers, and now what you can do is this is %t. So star a to print what? The star a is going to print 0. Okay, because it is the first location over here. Right, so star a. Now if I do sort of star a plus 1, then it will print what? It will print 1. But the address will be again, I mean, I think this addressability, it's kind of, you know, not always it will be like byte addressable, etc. But let's see that what is the, so we'll see that again. So this is the pointer, and then so if I want to do this, so I'll say that star a plus 1 and a plus 1. So let's print this, that what is a plus 1, and then this is the content. So content, we know that it is 1, but we'll see that what is the address. And now you know that in array, since it is continuous location, so this is one after the another, but each of these requires 4 bytes. Okay, so let's print. So this, right, so the last 4 is A484. My guess is that if I do just A, then it is going to be the same thing with A480. It would be, let's say, A480. So let's see, let's check that whether that is indeed the case. I don't do plus 1. Okay. Oh yeah, because sorry, I mean, because every time you run the program, the different location will be allotted. So I think let's print both a and a plus 1 here. So then we will know that what is the distance between the two in this. So you see that the first one, the 0th location, it is D60 and then it is D64, then it will be D68 and then D6C. Right, so 9D4, 9D8, 9DC, right, so there is a distance of 4. So when you do plus 1 internally, because depending upon the type of this thing, it incremented these locations. Now instead of, let's say that you take something that is bigger, so let's say that I'll do double. So for double I have to change this to, I think, LF, right? For double I am hoping. So this is still plus 1, plus 2, plus 3, plus 4, but you will see that it will jump by 8 in this case, because of this 8 byte thing. So it depends on how many bytes are basically how much address away element, and it will automatically calculate. So when you say plus 1, it doesn't mean that just add 1 to whatever the address is. It's saying that whatever A is pointing to, how large that object is, go to the next location where the object of same type can be stored. So that is how it is interpreted. Okay, and let's see over here. So now you see that now there is a difference of 8, that it is B78, and then because this is hexadecimal, remember, so this 8 plus 8 is 16, and so this becomes 0 because it's mod 16, 8. And this continues all the way. So it is not only for double, but I can have a struct. Okay, so let's say that one int and one char. So let's do like this, and especially char, because the thing is that since char is not aligned, what is going to happen is that for this particular struct, it is going to allocate more memory than 4 plus 1. And now I want to declare an array. Let's say that size 2 is enough. We just want to know that how much away they are from each other, and I can initialize it with so 2 struct, and each of them have 2 elements. So I will say that first is 3, and this is, let's say, A, and this is let's say 53, and the character is, let's say, B. Okay, I'll just use A here because I have printed. And okay, now obviously it's not a double. What I have to print is that I want to print the individual field over here. One is int and one is character, so that is what I am going to print here. So it is star A. So now what does star A mean? So star A is going to point to the first struct inside this array. So it is going to point to this thing, right? But now if you want to access 3, then you know that what you have to further do. What you have to do is star A. I want to access this field dot A. So then it is going to print 3 star A dot B, and this one, and similarly let me just do it like this. just a plus 1, right? So this is what we want to print. And let's see that how much so whatever is the difference, that is the size allotted for one object of this particular type, something t. And you will see that usually it won't be 5 because the alignment won't be there. So I mean, if it is a multiplied by, it is a multiple of 4, then it would be 8 away from each other. Okay, so let's see. So you see that the distance between these two is 8, and then you are printing the values over here. And what I did was just plus 1. So when you say plus 1, it doesn't mean just add 1 to whatever the location. It means that you want to go to the next element, and that is why the type of the pointer itself comes into play. So since a itself is of type what? It is of type something underscore t pointer. So it's going to say that whatever is the size of something underscore t, you have to add that many sort of byte to point to the next element. Now, okay, this is cumbersome. So star a and then dot a. So there is a shorthand. I hope that I can do this. So I think the shorthand. So star pointing to a struct or something like that, and if you want to access a field, then this you can do, right? So this is a shorthand operator, arrow operator, which is saying that look at the struct pointed to by a and then access the field a. So this also you can replace by ab, and now this. So all you are saying, now this arrow operator is just a shorthand operator. What you are doing is that if this is a pointer, you will look at whatever the struct that this is pointing to and access the field a. Similarly here access the field b. Right. So now you know that essentially when you have array, it is just laid out one after the another, doesn't matter what the object is. And when you do things like this, so when you do an addition between this, then it is going to the next object. So it just doesn't add, because if you add 1 to 980, it will be 981. But that's not the point. It's not going to add to this number. What it is going to do is that since I am pointing to struct, this struct requires 8 byte. So when you do plus 1, it is going to add 8 over here, and it is going to point to this particular thing. So this addition inside a pointer with a number is nothing but that you have a pointer, and now you want to so this number is an offset, that you go that much offset away from this pointer and point to that location, that new location. Okay, so I think maybe this is kind of sufficient, or maybe so I can explicitly take a pointer to this thing, and that is also going to be the same. So let's say that you can take a pointer for anything. So I'll say pointer p is equal to, you want to point to the first element. So star a is 0, which is nothing but just a, but sorry, not ampersand, right? And then what can you do? I can now do this one. And now you will see that since p and a are sort of exactly the same, they are alias to each other. When I say alias to each other, means that both of them are referring to sort of same object, which is this 3 comma a. So then when I do a plus 1, you will see the difference between this p and a plus 1 also to be 8. right? So there is a difference of 8 between the two. And not only that, I mean, since it is also pointing to A, I never explicitly said that I want to go to the first element, but I can actually do so over here. Right, and this also works. And not only that, what I can do is, I am guessing that this also should work. Because as I told you that when you have the index, it is nothing but saying that you go to essentially, so index of 1 is the second element, go to the second element, and even when you do addition, it takes the type into account. So it will say that where will be the next object of the same type can be stored, so you go over there. Both of them are same thing. So this also should have the same effect, and yes, it does. Right, so in all of these varieties I'm printing this. So it's very simple. What is a pointer? The set of values is nothing but addresses for pointer, and then you can do this addition. We'll see some other examples and what else also you can do with pointers, but I think that we are close to the end of the lecture, so I think, yeah, we will stop here. Thank you very much.